All right, if you're a maker, you definitely know this feeling. You have a brilliant idea for a 3D print, but when you go to model it, you're just hit with this wall of free software options. It's an amazing, but yeah, it can be a pretty overwhelming world out there. So, how do you cut through all that noise? You've got this spark of an idea, but which tool will actually help you bring it to life without a massive headache? That choice paralysis? That's exactly what we're going to solve right here. Okay, let's dive right in. The first and honestly the most fundamental choice you have to make boils down to this. Do you want to build your model with code or with clicks? These are two completely different philosophies for creating in 3D. On one side, you have visual modeling. This is what most people picture, right? Using a mouse to push, pull, and sculpt a shape on the screen, kind of like digital clay. On the other side, there's programmatic modeling, where you define your model with lines of code, literally describing its geometry with text. You know what? Let's use an analogy here, because this makes it crystal clear. Programmatic code-based modeling is like writing a very precise recipe. Every single step is defined and totally repeatable. Visual modeling, on the other hand, is like sculpting that same object by hand. It's more intuitive and freeform, for sure, but it's way less precise and a lot harder to change later on. And right here, you can see that whole recipe idea in action. This is a language called Cad query, and you don't need to be a coder to get the logic. Each line is just a clear instruction. You start a new design, you draw a box with specific dimensions, you find the vertical edges to round them off, and then you find the top face and drill a hole. It's just a logical, step-by-step construction that's perfectly repeatable every single time. So now that we have our two paths, code or clicks, let's meet the main open source players on each side. These are the tools you're most likely going to run into, and each one has its own special superpower. First up is free CAD. If you're looking for a traditional visual CAD experience that can do pretty much anything, this is your starting point. It's basically the Swiss Army knife of open source 3D modeling. So what makes FreeCAD such a powerhouse for engineering? Well, it's fully parametric, and all that means is that everything is based on numbers you can easily change later. Adjust one dimension and boom, the whole model updates automatically. It has these dedicated workbenches for different tasks, like sketching in 2D or designing parts, and it can handle all the professional file formats you'd expect. Bottom line, this is your go-to for serious mechanical parts. Now let's switch gears and talk about a completely different philosophy. Meet Blender. While FreeCAD is for the engineer, Blender is for the artist. It's all about creating beautiful, organic, and really complex shapes. Just look at its strengths: sculpting, animation, and handling complex curves. If you want to design a character, a piece of art, or anything with flowing, non-mechanical shapes, Blender is the absolute king. And its 3D Print Toolbox add-on makes it fantastic for us makers. Okay, now we're crossing back over to the world of code. This is Scad. It's the original, the classic. It's a simple, no-frills tool that does one thing, and does it very, very well. It turns simple scripts into 3D models. The beauty of Scad is really its simplicity. It's fantastic for whipping up a quick prototype, a simple bracket, a custom enclosure, when you just want to get an idea out of your head and onto the print bed fast. And finally, we have the modern evolution of programmatic CAD query. If Scad is a simple script, think of CAD query as a full-fledged engineering library built on Python, which, is one of the world's most popular programming languages. This is where code-based modeling gets incredibly powerful. CAD query uses a professional-grade geometry kernel. That's the core engine that calculates the shapes for extreme precision. This makes it perfect for those really complex, parameter-driven engineering parts. And its integration with tools like Jupyter Notebooks just makes it incredibly flexible. Okay, I know that was a lot of information. So how do you choose? Don't worry, we've distilled it all down into a simple cheat sheet to help you match your project to the perfect program. This table is your quick start guide. Need to design a precise parametric mechanical part? The chart points you directly to FreeCAD. What about something organic and sculpted? That's a job for Blender. Need to fix a broken 3D model file, that STL file that you downloaded? MeshLab is your expert. Just find your task and you'll find your tool. But here's a pro tip. The best makers don't just use one tool. They build a toolkit. Beyond the big four, there are specialized programs that are the absolute best at one specific job. For example, MeshLab is the undisputed champion of repairing and optimizing mesh files, those STL files you download for printing.
And if you're designing something like a drone or an RC plane, a tool like XFLR5 for aerodynamic analysis is absolutely indispensable. The key takeaway here is that a great project is often built using a workflow of multiple tools.
To make this all concrete, let's just walk through a real-world example. Let's say you want to design and 3D print a custom wing for a radio-controlled airplane. Here's how the professionals would actually do it. Here's how that multi-tool workflow plays out. Step 1. You'd start in XFLR5 to analyze the aerodynamics of your wing profile, then use that data to generate the 3D model programmatically in CAD query. Step 2. You could even use Python libraries to optimize the internal structure for strength and weight. And finally, step 3, you bring it all into FreeCAD for a final check before sending it to your slicer. See? Each tool plays its part perfectly. We've covered a ton of ground, from high-level concepts all the way to detailed workflows. So after all that, what is the single best step you can take to get started on this journey? Our single biggest recommendation is this: start with FreeCAD. It is the best place to learn the core concepts of parametric modeling, how constraints and sketches work. Once you've mastered that visual approach, graduating to CAD query will feel like a totally natural next step, letting you apply those same concepts with the incredible power and repeatability of code. And that brings us to the end. The right tool is always the one that fits your project and your way of thinking. So as you start your next project, ask yourself this: what do you need most right now? Is it the raw speed of OpenSCAD, the artistic power of Blender, or the engineering simplicity of FreeCAD? The choice is yours.